All right. Well, today we have Chris with us. Thanks, Chris. Hey,
Yeah.
be sure you introduce yourself a little bit more. Tell people what you're working on, kind of your background, how long you've been in the lab. And then I thought it was a good idea. Not so many of you did it, but later on, if you have a question, as you ask the question, introduce yourself a little bit more to Chris. We won't go around the table and do that at the beginning, but take a chance to be sure that he knows who you are when you bring up a question. And I'll turn it over to you, Chris.
Cool. So I just finished my undergrad. I finished in December, and so this past semester is my first semester in my master's program with Dr. Nelson. I am studying different flood mapping methods as part of the Severe Amazonia project. So we're looking at comparing different flood mapping methods in areas in Peru and Brazil. And so that's mainly what I'm working on. I've been married for a few years. We have a 9-month-old son he's fun working at home. He's a lot of fun. He likes my desk and computer and all that. So we have a good time. I'm from Orem. I've lived around here forever. So that's a little bit about me. Just to start off, quick question. How many of you have gone through the virtual machines exercises yet? So most of you have gone through it. Does anyone have any questions about it before I thought we'd go over it a little bit, but I wonder if anyone had any questions, things that didn't make sense to them before we jump in.
My question is I usually use more Docker because I like more Docker than virtual machines. And there was like a container section. I was thinking is there any reason that I actually need a VM? Do I need anything else other than a server for applications, or I just need Python and that's it?
Well, it totally depends on what you're doing. This is like a brief introduction.
Okay.
I think you've had more, because what's your background, Daniel? Is it more in the?
I'm IT. I've been a developer for a while. So yeah, it's just
right. So this topic, you've been exposed to this a lot more than a lot of people who've been just studying civil engineering. So, I think that containers are the better way to go if you can use it. So
yeah, I like Docker more than virtual machines. I think they're easier, but yeah, I just wanted to know if there was a specific virtual machine that we ever gonna need to actually install or something like that.
And no, honestly, this one is more like if you need it, refer to it. But the biggest reason that we had used virtual machines in the past was we all had Windows computers, and then doing Tethys development on a Windows machine doesn't work very well. So then we would install a Linux virtual machine on our Windows computer to develop in Tethys. But now they're trying to get a lot more Macs, and so then you don't. So the main reason for a VM is kind of gone.
Yeah. Okay. Makes sense. Makes sense.
Anybody else have any questions? No? I must have written a really good exercise. Actually, the funny thing is I've only used a virtual machine like once or twice. So I did a lot of reading to nail down the concepts. I'll go ahead and share my screen. And we can go through this. And then feel free to speak up if you have any questions. This one is, it's shorter than some of the other tutorials, right? You guys have done like the Python and the one last time with Rohit. There's a lot more. But I guess some of the things that I wanted to talk about was kind of what Daniel asked, was situations when you need a virtual machine. And I already kind of talked about one, which is if you're doing Tethys development and you only have a Windows machine. Another one is a lot of engineering software like ArcGIS, and then other modeling software, especially in civil engineering, AutoCAD, things like that. A lot of those only run on Windows. And so if you don't have a Windows machine, install a Windows virtual machine so that you can run some of those softwares. The problem with that is a lot of those softwares, you're analyzing large data files. And so you need to have like a lot of resources. You have to have a pretty beefy computer in order to have a virtual machine big enough and powerful enough to do a lot of what you're going to do anyway. So I think it's better to just find a Windows computer. But if you're working in the lab and you have a class, you need to do some homework, and you don't always want to go over to the CADM lab, or if we're stuck at home, you never know, and you need to run something. There's ways to get things installed on your computer, but this is just one option to be aware of. And then some of the more advanced things, some of the more advanced workflows that we have in the lab, we use cloud computing. So I just kind of want to talk about that for a minute. This exercise was kind of leaning more towards VMs. But before I go on, did everybody do the exercise? Did people try to set up a virtual machine on Ubuntu? And did anyone have any problems with that, or?
I tried. I had a bit of an issue at the end. I think I'm gonna need to try again and like send screenshots of what I was getting and then send it to you, and then maybe that could help with the course. But I know I was having issues, and I'm not sure if I was the only one or not.
Was it like installing VirtualBox, or was it once you had that installed, did you get that to work, or was it after that?
Yeah, it was at the very end. It was like the very last step, just trying to, like, I had Ubuntu installed,
Oh,
and
okay.
the virtual machine installed. It was just the last little bit of like getting it to work. And then
Oh,
also, it took me like an hour and a half to like download Ubuntu. So I don't know, because I'll be going through and like me and Alma are like putting these onto OpenEDX. So I guess like something would be nice, like the very beginning of the course, to say like, hey, like maybe start downloading it now. Because I got to
that's
the
a
end,
good
then I
idea.
was like, oh no, I have like an hour and a half of this downloading.
Okay, I'll put that. I'll just put a note here. Yeah, it totally depends on your internet. My internet at home isn't that good right now. The free Google Fiber, and it's like struggling. So I always just have to remote into the campus computers if I need to download something. Okay, that's good feedback. Did anybody else have a problem with the exercise or any questions? There's a lot of good YouTube videos, and that's honestly what I just followed one when I did it, when I was setting this up. So anybody else have a question on the exercise? No? That's great. Okay, so back to this point. Do I need a virtual machine? You guys have you guys done some of the trainings with getting the streamflow forecast and looking at the forecast data? Have you guys looked at that yet? I think Dr. Nelson had sent out an email that there was like some trainings from a thing we did in Peru where he kind of explained the streamflow forecast. Have you guys learned about that at all yet?
Yeah, we started doing that. At least the ones I was trying weren't completely functional.
Okay.
One of them, Riley reached out to me and kind of let me know some things to do. So I need to go through that with him to fix one of them. But I think I think all of us have started doing those though.
Okay, so you guys have had some exposure to the streamflow forecast. So one of our big uses for a virtual machine right now is the streamflow forecast. So what happens is there's a workflow that runs every night where it downloads the input files and then does all the calculations and processing to generate the forecast. And we used to have that running on one of our servers at BYU, but then we got to deal with Microsoft Azure, which is a cloud computing platform that Microsoft has. So what happens is you can go on, you get your account, and so you go in online and you can set up a virtual machine. So this is like in the cloud. So they have servers at different locations, and then you basically rent out space on their server, and you can set up any kind of computer you want. So you can decide how much storage you want, how much RAM you want, how many processors you want, and then you pay for like how much you use it. So we got some credits with them, and so we have a virtual machine stuff that at like 7:30 every night it turns on and it downloads the input data for today's forecast, and then it does all the processing, creates the output files, puts them in the right place, and then it shuts off. So that's another example of a virtual machine. Those type of workflows, and those can be automated in lots of different ways. You don't necessarily need a virtual machine, but that's just one example that we've used. And then also you guys talked to Rohit last time, but he's done a lot of work doing things on Amazon Web Services, is another cloud platform that I didn't really go into, but some of the benefits of these cloud platforms are that you only pay for the computing power that you're actually using. Because if you buy a physical machine and you need like a ton of storage, a ton of RAM, you know, you're paying for that, and a lot of the time you're not using it. But the idea with some of these cloud computing platforms is that you only pay for what you actually use. So that's something you'll probably encounter more and more as you work on different projects in the lab. And I think a lot of computing is going that way. And in the future, I think a lot of maybe places you work for, things like that, will be using these cloud computing services to help be more efficient in the cost. And it's easier because you don't have to maintain your servers and things yourself. They have somebody else doing that you're paying them to do, right? But then you only pay for what you use, so it's a good trade-off. So I guess, could somebody, well, let's see. Trying to think of the best way to go over this. This one's pretty short, and if you guys have gone through and don't have many questions, not sure what's best to go over, but I guess like Daniel was asking at the beginning, he was mentioning containers versus virtual machines. And one of the drawbacks with virtual machines is that you have to install an operating system on it. So here's a graphic that kind of shows the basic of a physical virtual machine, like the one in the exercise where you install a Linux machine on your Windows computer. We'll use that as the example, but you have the host hardware, so your computer, your laptop, and then you have Windows running or Mac, and then you install VirtualBox, which is the hypervisor. The hypervisor is the software that manages the virtual machines and how it interacts with the host. And then you create a virtual machine, like in the exercise, a Linux virtual machine, and then you have to install Ubuntu on it. And then you can have your other apps installed, like if you want to install Tethys, or you have an IDE like PyCharm that you're using. So there's just a lot of layers to it. Whereas with a container, this kind of is all wrapped up into one thing, and it uses the host operating system to run your app. So it's much more efficient and better way to go. You can kind of think of a container as kind of like a custom application that you set up everything you want to work, all the applications you want, you install several different things on it, but then you can share that with somebody and they only have to install the one thing. You only have to set up the container instead of having to recreate the whole environment that you had set up. If you guys do more test development, you'll run into containers more. There's some more reasons to use Docker containers when developing with Tethys. But for now, I think it's good if you just understand the concepts so that when people are talking about things, you know what they're referring to. But as you get assigned more projects and things, you'll have more experience with these, because this is a really broad topic, and depending on the project you're working on, the specifics of what you do change. But it's important to know that with the virtual machine, you're pre-allocating your resources, your RAM, your hard drive space, and your processors, whereas with a container, it does it on the fly and it just uses what it needs. Does anyone else have any other questions on the virtual machines or anything related, or any other questions you have?
I guess you've written a perfect training module, Chris.
I guess, man.
I
Give me the
I do
diploma
agree
right
that
now.
you don't need to understand everything about this right now. Just recognize that these are some of the things that we're involved in using and that you might have to learn more about at a given time, depending on your project. But any other questions for Chris? Because I don't intend for these to just take an hour. I planned an hour of time, but it takes as long as it needs to cover, review and answer questions. So be sure you ask your questions on this or anything else you'd like to ask Chris now, if you would like.
Well, if you guys don't have any questions now, that's fine. I'm very willing to help out where I can. More of my experience in the lab has been on the ArcGIS side. I've done a little Tethys development, and I'm doing more now. I can try and answer questions about that, or anything, or I'll just point you to somebody else who may have a better answer. But if you ever have questions, you're going through tutorials and you're unsure, feel free to reach out. Most of us are very willing to help. I mean, I'm always asking other people for help learning things, so don't feel like you're bugging anybody, because I know that was something I kind of struggled with when I started. I didn't want to like bug the grad students because they have lots going on, but sometimes you can save yourself a big headache if you just ask a question early on. Now you should try and figure things out on your own too, right? But don't be afraid to ask questions. We're all very willing to help, and especially now where we're all working separately, it can be hard to get the help you need. So get on Slack, send me a message or whatever.
Thank you, Chris.
Be looking forward to getting to know you guys better. It's kind of hard, we're all separate, but make sure you guys tune into the weekly meetings and it'll be good. Hey,
Thank
Dr.
you.
Nelson,
Yeah.
remember how we used to like at the meetings have like everybody take like a PowerPoint slide and kind of introduce themselves?
Yeah.
Do you think we should do something like that? Or we could, because I think it'd be nice to kind of get to know everybody a little better and have, the new people also get to know the people who've been here a while.
Yeah, I think we can do something like that. And maybe what we'll do here soon is have now that the lab web page is kind of updated, we can just have everybody go and take a turn at their LinkedIn spot, and then maybe at the end of the summer we can have everybody share a slide about something awesome they did this summer, if we ever get to leave our house and do something awesome.
Yeah.
All right,
Well,
thanks everybody. We'll see ya.
See you
Thanks,
guys.
Chris.
Thanks,
Yep.
Chris. Thank you, Chris.
We're glad to have lots of new people to help out. We got lots of stuff to work on, so you joined at a good time.